Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. CmNO4H+, hot, acidic, concentrated, is a strong oxidizing agent that cleaves carbon-carbon double bonds. Each alkene is oxidized. Internal alkene carbons bearing to carbons become carboxylic acids, -CO, terminal is equal to CH2 groups are oxidized to CO2, and is equal to CH groups give CO. Step 1. Analyze the product. The product shown is a molecule with 3 carboxylic acid groups and 1 hydroxyl group plus CO2 as a byproduct. Looking carefully at the structure, it contains CO groups attached to a chain with a CH unit. The CO2 byproduct indicates there was a terminal is equal to CH2 group in the starting material. Step 2. Work backward from the product. The presence of CO2 means one terminal vinyl group is equal to CH2 existed. The multiple CO groups mean multiple C is equal to C bonds were cleaved. Option B shows one vinyl cyclohex, 1Na, a cyclohexene ring with an exocyclic vinyl group at C1, the ring double bond and the vinyl substituent share C1. This compound has two double bonds, one endocyclic, ring C is equal to C, and one exocyclic vinyl, CH is equal to CH2. Step 3. Apply CmNO4H plus oxidative cleavage to option B. 1 vinyl cyclohex, 1Na. The ring double bond, C1 is equal to C2 in cyclohexene, when cleaved gives two CO groups, both carbons are internal disubstituted. The vinyl group CH is equal to CH2 at C1, the is equal to CH2 and gives CO2, terminal methylene, and the internal is equal to CH attached to the ring becomes part of the CO from ring cleavage. Cleavage of the ring at C1 is equal to C2 opens the ring, giving a linear chain with CO at both ends. The vinyl cleavage at C1 adds another CO at C1 position. The net result from ring opening of cyclohexene with a vinyl at C1, hook CH2, 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 CH, CO-CO plus CO2, which matches the observed tricarboxylic acid product, with the extra hydroxyl possibly from the oxidation conditions on the secondary carbon adjacent to the cleaved site or as drawn in the product structure. Step 4. Eliminate other options. A. 1. 4-divinyl cyclohex, 2Na has the ring double bond not at C1 bearing the vinyl, giving a different cleavage pattern, and to CO2 molecules plus different acid fragments, does not match. C. A cyclopentene with an allyl group would give a 5-carbon diacid plus other fragments, does not match the 6-carbon framework of the product. D. Similar cyclopentene derivative gives analogous 5-carbon products, does not match. Option B. 1 vinyl cyclohex, 1Na, upon CmNO4H plus oxidative cleavage of both double bonds, produces the tricarboxylic acid shown plus CO2, matching the given product exactly. Therefore, the correct answer is B. Therefore, the correct answer is option B.